Hi guys, morning. So this is the mystery ATX supply, yeah. The one that like nothing seems to be wrong with it, but it doesn't work. And this has stirred up quite a bit of interest. That's great. That is. That's what I hoped would happen, to be quite honest. And one of you guys, Daniel. I don't know how to pronounce your surname, Wagner or Ashner or something. Anyway, I'm sure you know how to pronounce your surname, but Dan, listen, you were kind of on the right track with this, mate. Okay, so what Daniel suggested was that I had a short circuit on one of the outputs, and that the power supply was actually powering up, but the voltages were all very low, so this analyzer won't pick it up. And I mentioned to Dan that I'd actually checked for short circuits, but that wasn't in the video, so it was very reasonable. He thought maybe I hadn't. Yeah. But the other reason is when I switched this on, if you remember, we started off with a light bulb here. Yeah. When I switched on, the light bulb pulsed once and then went out. And I tried it again, it pulsed on and go off. If there was a heavy load on here, which a short circuit's a heavy load, yeah, the light bulb would come on. And so I mentioned this back, and Daniel says, "Oh yeah, I didn't think of that." But anyway, what you said, Dan, has got me wondering now about this. So this is the analyzer, yeah. So what I thought this morning is, let's have a look to see if there's actually any voltage coming out of this power supply, even though this doesn't light up, doesn't do anything, yeah. So I'll just switch it on. Can I arrange this so you can see the light bulb? I've got two of these light bulb units. The other one's on top of my variac over here, just back under there, yeah. So watch. I'll switch this on, yeah. See, light pulses once and goes off, yeah. So that's how I know there's no short circuits on the load, yeah. So we look at this power supply now, and we go to one of the red wires. Actually, there's something I have to change the switch on this. It's a little bit iffy. It's on now. I go to the red on here, and let's see what we've got. Just go in. And look, I've got 7.2 volts on the 5-volt rail. So this actually is running. Yeah, it is running. There's no load, and it's running. We go to the 3.3 volts, and it's 3.4. It's close, yeah. The 5 volts is much too high, and the 12 volts is only 0.65, so it's very low. And I'm thinking now that this analyzer uses a 12 volts to power it up. And if the 12 volts isn't there, you can't power on. Which, if that's the case, that's just a stupid design. Do you know, I did a review about this thing, and I said, yeah, it's great. And now I've used it for a little while. I found out, if you've only got 5 volt standby, it doesn't come on. So that's just useless. It doesn't tell you got 5 volt standby, which it should do, if it's just in standby. It looks like B, now, if you haven't got 12 volts, it doesn't come on. Piece of bloody, I'm sorry, but now I'm thinking it's almost a piece of junk, yeah. It's very good at testing the power supply if it's a good power supply, but if there's a problem with the power supply, it's not very useful at all, is it? Is it, guys? I mean, you know, yeah. Okay, I pay like six to €7 for it, but even still. So rant over for now. Yeah. So if we just go from ground, and I'll do this now. I had done this previously. And we know from the light bulb there's no shorts, but let's just do it now. So black to yellow, yeah, with 100 ohms or so climbed, yeah, that's okay. 5 volts is 20 ohms, and that's quite normal for 5 volt rail, you know, to be a load on that. That's not unusual. And a load on the 3.3, and again, that's not unusual, yeah. So I'm interested actually if any of that load is actually from this. Let's just have a quick look. Again, out of interest. So 3.3, yeah, an 8 ohm load. So you know that's okay. That's like less than half of an amp. Yeah. The 12 volts is just high, and the 5 volts, 50 ohms, something like that. And that's the minus 12 is just high. So we haven't got a short on here, but we've got a problem with the 12 volts on here, which I suspect is either an open circuit, yeah, between the the rectifier diode or a faulty rectifier diode, or a low value resistor, which is basically the same as an open circuit. So what we're going to have to do now is have a look to see where the 12 volts on this comes from. Yeah, so let's have a look at that. Okay, so we can see the yellow wires all come in here, yeah. Let's just zoom down on this for you again. Yeah, so the yellow wires come in on this pad, and we know the 12 volts got something like what was the resistance to ground on 12 volts, just to check on here. To one of the black again. This is a black. Sorry, can't see. And 12 volts is reading about 100 ohms, yeah, to ground there. And this, we can see here, the yellow wires are here, yeah. So we go from here, and this is ground, about 100 ohms. That's fine. So we know that's the right one. So this has got to go to one of the diodes. So on this heatsink, there's two 3-leg diodes and something else. I'm not sure. Something else down in here. This thing with like 2 legs splayed out going down to the board. Yeah. But anyway, the 12 volts cut is here. This has got to go to one of these diodes somewhere. That's 100 ohms. Doesn't go to that one. Doesn't go to this one. I'm not really sure where that goes to at the moment. Well, let's have a look at. Oh, there's another one here. Doesn't seem to go to there. It seems to go to some sort of component under here, which might be a resistor. So from the end of this track here, it looks like it goes over to there. No, that's 100 ohms. Doesn't go to there. Doesn't go to there. I'm not sure where this goes. This must be a capacitor here. I'm not sure what this thing is. It's a big thick leg here. And I can't see down in amongst all this lot to see. The diodes. Let's look at the diodes. So we'll go to diode mode, yeah. So look at the diodes. So there's one here, and this looks like some slightly dodgy soldered joints on this as well. Well, that reads low. We need to take that out and have a look. There's another one here. It's even lower. Okay, we need to take these this heatsink off with these diodes and this middle device. The middle device goes between here and here, and it reads short, but I can't see exactly what that thing actually is. It's under here. Okay, let's get this heatsink off. Let's have a look to see what we've got here. Okay, so this is what's on the heatsink. I wasn't sure what this thing was, and look what they've done. They've taken 2 diodes and effectively connected them together and soldered them to this like metal thing and bolted it on. That's like, instead of using like, you know, one of these devices but a bit higher powered. It's amazing. Some of the things they do with these, I mean, come on, you know, just buy a diode, double diode, and stick it in there. I can't believe that the cost of manufacturing makes that much difference. Yeah. So anyway, let's have a look. So these should be Schottky diodes, I would think. So they read quite a low forward voltage drop. Yeah. Yeah, and then if we go the other way round, and they're okay. And the same with this one. And then the other way round. They're okay, yeah, nothing there, nothing there, nothing there. And then this thing, yeah, they're actually using the heatsink as like the negative terminal of it, yeah. They actually, so this tag of the heatsink here is like the negative terminal. Yeah, we have 2 diodes, and then the other way, they're okay. And this is not; these are not Schottky diodes because the voltage drop is higher, yeah. So that's that. So they're okay. What I have noticed, now I'll zoom down on it, is that there seems to be a lot of problems in this area. I was starting to think, well, I've taken the glue off this and that might not have helped, but You've got a number of inductors here, and I'm thinking, well, if there's nothing on the 12 volts and the diode's okay, the chances are there's a broken track somewhere between whichever diode feeds the 12 volts and here. And there's inductors and some low value resistors down here, so those seem the obvious things to check, yeah. But what I have noticed is the ones at this end, these are all very wobbly, yeah, look. Yeah. And if we look underneath here, and I'll zoom it down, you'll see I've got some broken tracks, or broken pads. I'll just zoom in. Okay, so this you can see quite clearly, I would think, here, that this is broken, yeah. And this capacitor here looks like it's fractured as well. The one on the end, this one looks actually okay. It's not moving so much. It's just this capacitor and this inductor mainly, which are these two, yeah. Sorry, these two. You can see the whole thing's wobbling around. This might not have helped. I took the glue off, but still, there's another one here. So let's fix that first, yeah. And then what I'll do is then I will just make sure that there's effectively continuity through all these inductors and these low value resistors, yeah. And if there is, we'll stick the heatsink back on and have a look to see what we've got. Okay. So I'll just do a little bit of soldering work on this. So I can see as soon as I'm touching this with a soldering iron, this pad's just come off, yeah. This one I've managed to solder, but what I'm going to do is I'm going to get a bit of, this is just a bit of stiff wire, yeah. It's a bit of old network cable I've stripped. It's nice stiff copper wire. So I'm going to use this to repair the damage, yeah, even to this one, which seemed to be have soldered okay. So we'll just effectively get another blob of solder over here somewhere, yeah. And I'll actually run the wire through, yeah, like so. It just gives it, you know, a much more solid connection, basically. You know, rigidity, that was the word I was looking for. Gives it a bit of rigidity, so it should solve this from happening again. So that's that end of that one. Again with this, we'll come from across here. Okay. The tracks on this thing are pretty awful, you know. The quality of this PCB is bad, yeah. It's bad. So that needs to go to there. Okay. Take that one off. So that's the this capacitor is nice and solid now. Now we've got this inductor here, yeah. And I can see here that both the pads are broken again. So we'll do the same. So we'll take a bit of get a bit of solder on it first. Yeah. At this point, I'm expecting this pad will probably just come off. Yeah, mostly it did. I think I've bridged it with a bit of solder, but again, I'm going to put a bit of this wire in here for some rigidity. Yeah, so I'll just sorry, if I'm out of your view. I'll just tin the end of the wire, and again, I'm going to fix this into here. Okay. A little bit of flux on this one, just to help it along a little bit. Okay. That's better. Okay, so again I've put a piece of wire into that to get a connection there. That's now solid. And the other end is here, yeah, just below where my little inset picture is, yeah, my picture in picture. So this one we will scrape away a little bit at the PCB edge here, yeah, this green stuff, whatever they call it. We'll scrape a bit off there. Okay, and again, bit of wire. Bit of flux again on this one will help. Right. Again, I'm going to insert a bit of wire into it. There. That's nice and rigid. So these now don't wobble around anymore. Yeah. This one looks okay. What with a dry joint maybe just here, so let's just go on that one. Again, I think we need some forks. It's like as soon as you touch this PCB, it melts basically. The tracks melt, yeah. Where is it? I've lost where it was. Oh yeah. It was down here. Okay, and the other end, that looks okay. That end looks okay. Okay, so we've fixed that problem. Yeah, they're nice and solid now. Let's have a look then. See where the inductors are. And make sure they're good. Yeah, make sure I've got good connections. I suspect this is the cause of all the problems, to be honest. So this one here comes from this pad here. Through the inductor, so to here, yeah, to here, and then to here. So that's good. Yeah, that one's good. There's another inductor just inside of it. Here, yeah. Let's see if we can find where that one is. That one appears to go sideways across here. Yeah, and we've got a connection there. That's that one. There's another one, a blue one, kind of in here, possibly between these two. Yeah, that was good. Sorry, where are you? Yeah, that's this blue one we can see here. Yeah, and then we have a big one, which is a little bit wobbly, but I don't see anything wobbling on the other side. No, that seems to be okay. And there's another one. So that one seems to be solid. I think that's there. Right, one of them I think is here. That's the tall one. The other one's here. I think you can see them because it's like sorry. The tall one is where was I? It's here. Yeah, and you can see them because they're like these big, thick, chunky legs there and there. Yeah, another one here from there to there. Yeah, again that looks okay. So, and there's another one up here somewhere. Yeah, that one reads okay. Yeah, those thick legs there. I can spot them now. So they look alright. Then we have a couple, 3 high value resistors, or probably low value resistors. 2 are down here at the front. One's across here, I think. Yeah, these will be the ones that put the loads on the outputs. Probably. One's, where is it? One's here, from here to here. Yeah. And it's actually, let me zoom this out a little bit because that's probably very hard for me to do in IFPCNVRU. Okay, see if that's a bit easier. So one of the resistors is here, and it seems to be brown, black, brown, yeah, which is 100 ohms, yeah. And I was obviously actually get a connection onto it. So one end's there, and the other end goes underneath. The other end probably goes to ground. It probably goes from here to ground, I would imagine. Where we know there's a ground? We know there's a ground here. Yeah, that's reading 100 ohms to ground, so that's one of them. It reads 100 ohms, okay. The other one is here, and it reads quite a low value. This is from the red. I can see it's connecting from the red, so this end might go to ground. And the other end goes into these reds, so I'm just get underneath the resistor. I'm on it. Yeah, 47 ohms, and that's on the red. Yeah, so that's I'm connecting to the red wires now, so we know that resistor's okay. And these are just load resistors; these are not part of the circuit path. The other one is back under here. One end, let's just check it to ground again. This is the 8 ohm. Again, this is going to be like a load resistor. It's not part of the circuit path. So it's just these inductors, yeah, and we've measured all them through. So let's put the heatsink back on here and let's see if it actually works now. In fact, we can see it now just before we put it back together. So under here, this is the orange wires coming in here, yeah, and this should go to one of these 3 diodes, the middle pin, and it goes to that one, yeah. The yellow wires come in here, and this should go again to one of these diodes, middle pin, goes to that one, yeah. And then the last one here, these the red coming in, and these go to the middle pin of that one. So that's all 3. The negative will go somewhere or other to a little diode, probably just a little diode under here actually, 12 volt minus. Okay, so we've got a circuit there from each of the diodes now to the output, and we know the diodes are good. So let's see if that's fixed the problem. Okay, so it's all back together. Let me just make sure this is set to limit on the light bulb. Yeah, set to limit. Let's see what it does. Yeah, let's see what happens to it now. And it still doesn't work. Amazing, it still doesn't work. Okay, what have we got now on the voltages? Let's find the voltmeter. Yeah, I thought that would have had it, is the honest truth. I thought that would have had it. Okay, let's check some more voltages. So we have, start off with the obvious 5 volt standby. Yeah, so we have a meter to stay in there. We have 5 volt standby. Yeah. We have nothing on the orange now. Nothing on the yellow now. Nothing on the red now. Huh. I think I've stopped it. I think I've stopped it from running. I think I'll probably stop the pulse width modulator from running. We can check that out. Let's just go to Hertz mode on here, yeah. What pins was it? 11. 70, 30 kilohertz, no, it's still running. 30 kilohertz still running. That's interesting, because now we have nothing coming out of it at all. Oh no, tell why, we do have something. We have. What do I see in here? Let's have a look. Orange. 30 kilohertz. I'm seeing 30 kilohertz on the output. That's like Ripple. Nope. 3.3, nothing. 5 volts, nothing. 12 volts, nothing. Okay, I've succeeded in just making it worse. Oh, okay. I see what I've done. I see what I've done that might have made it worse. These two here are the big, like the 2 diodes you've soldered together, yeah. And the middle goes to this pad here, yeah. And I haven't soldered it. Okay. So that's not going to help, is it? So let's a bit of solder on that. Although I measured through to the diode, I must have been touching the leg and not realised I hadn't soldered it. So let's get a bit of solder on there, and then wonder why the focus went out while I was doing that. And let's just can you see it? Let's just check that to be certain. So this effectively is the heatsink, which is basically soldered to the board in a couple of places. Well, this is one end of it. You can't see, it's just over here. That's there, and that should now go to the 12 volts. Yeah. Let me zoom that out. You'll see what I'm doing. So basically, they're using the heatsink to feed the 12 volts. And this is one end of the heatsink. The pad came off, yeah, but it doesn't go anywhere. So this is one end of the heatsink, and this is connecting to here, yeah, which is the 12 volts. The other end of the heatsink I think was here. Yeah, it was. There's like the two metal studs that hold the heatsink in place, and that goes to 12 volts. Yeah. Okay, so that's what they've done, and that's what I didn't solder. Let's see what it does now, eh? Let's see if it's still worse than it was, or if it's improved matters. Yeah, it's all been a bit of a knot. It's been turned over too many times. This has. Okay, so the power's off. Just plug that into there, and let's just switch it on now and see what it does. Yeah. Ah, at last. It's bleeping because the 4-way isn't in, which is obvious. So let's connect the 4-way. There we go. It's bleeping because it took 90 milliseconds to power up, but I'm not too worried about that. So we have minus 12 is 11.5, plus 12 is 1.8, the other plus 12 is 1.8, 3.3 and 5.1, yeah? So it's good, it's working at last, the mystery's solved. Yeah, that was a good one. What are my thoughts on that? Well, Daniel, you came the closest to that one, unless there's more comments since this morning when I had a look. You were right for the wrong reason, yeah? But you were right. So this piece of crap, yeah, it's just caused a great mystery, but I tell you what, it made a great video, didn't it? I know about it now. I know about this. I could do with modifying this in some way, you know, so it actually makes the damn thing useful. I want this thing to power up when the 5 volt standby is there, not like when the 12 volts is there. Yeah, it doesn't make any sense. I'm going to have to open this up and see if I can modify it to do that. I think I probably could, you know. Maybe just by using like a little step up buck converter. You can buy the little things and wire it to it one way or another, even if it's sticking out the top, yeah, and convert this so that it gets its power from the 5 volt standby. Anyway, Daniel, nice one, mate. Well done. Thanks for everybody else who commented. Thanks for all of you sitting and watched the very long video. I hope you've learned as much as I have. That was obviously failure of the test equipment, yeah. But like a good Scooby-Doo mystery, yeah, the problem's solved. It was a thing you saw in the beginning that did it all along. It was the butler, yeah, the estate agent, whatever you saw in the beginning, that's what it was. Okay, guys, see you all soon on the next one. Ciao for now.